Hi everyone, and welcome to TaskGen Ask Me Anything session. So today I'll be showing you how to use TaskGen for quite practical stuff, like how to code it out. But before I proceed, let me just run through briefly what's TaskGen again. So TaskGen basically uses JSON output methods, and specifically using StrictJSON, where you output like your user query, or for example, if you go execute some external functions, the output are all in JSON. All right, why JSON? Because JSON is much more concise than free text. So, those kind of large language models, they are trained on conversational text. Like, look at this chat dev. In order to decide what software to use, they have to spend like 100 over words just to discuss between two agents. If you use JSON and ask it, what programming language should I use? It comes out like that, like 5 or 6 words. In tokens, it's maybe about 10 to 20. So it is like more than 2 or 3 times less verbose than conversational text. And why StrictJSON? If you compare to this, if I zoom in a bit more, you can see on the left here is OpenAI function calling using the JSON schema. And on the right here is StrictJSON. So you can see like all these type, object, properties, location, and so on. All these are summarized into like this location, city, and state type string. So it's like a twofold decrease in the number of tokens. And this actually helps in order to make the LM perform better. Because if you look at like just like the rope embeddings in Llama 2. If you increase your token length too much, your score here, this root L is basically just a heuristic to see how close the answer is to the ground truth. You can see that the longer your token length, the worse the performance, especially for this naive rope embeddings. So being concise is not just only for like aesthetics sake, it's also for performance. And that's why I decided to build a whole agentic framework using StrictJSON, and this is called TaskGen. So StrictJSON, I covered it before. I just want to go through one last thing before we talk about the code improper. So how does TaskGen actually work? You give it a task. Okay, instead of going through all the possible outcomes, which is like what a naive large language model planner will do, just list out the steps. Okay, we don't want that. We want to actually map the steps into equip functions or ground it in the tools that you give it. Because if you don't ground it, you can't execute the step. Like for example, if you're an agent navigating a world, if you say pick up the Coke can, but you have no action called pick up, you will never be able to execute that step. So you need to ground it in the equip function space. So this is a core concept in TaskGen. And then the thing is subdivision. So if you have a task that is better done by someone that is down the line on that. So like the meta agent deals with the higher level things like your manager, and then your inner agents maybe are like your workers that specialize in different things. You don't want your manager to do everything. You might want to call a specialized worker to do stuff. So you can actually call an agent within an agent. The agent is the function actually. So this is like what I call hierarchical agents. You can also call a function, like external function, or just call a large language model to output your stuff. So essentially, you call your function, you return back to the meta planner. The meta agent would evaluate whether the task is completed. If not, you go on to the next part and so on. So there's quite a bit of planning here where the meta agent will generate a list of steps. And then at each step, you'll evaluate whether or not the step is completed. And there's also this idea of shared memory and subtask completed. So subtask completed basically is a common memory shared between all the functions and agents and so on. So everyone will know what's the current progress. So it's something like a progress report. Everyone will key in like what they have done so that we all have the same context. Shared memory is basically if you have certain things like imagine if you are working, you want to have a QA database or some wiki, everyone can access that wiki and use it for their own tasks. So shared memory functions like that. So the key idea of TaskGen is that we want to be as concise as possible. And in terms of like sharing the context, sharing the memory, we want to be as specific as possible also. You only share what is needed, you don't share more than that. Because as what I repeated earlier, the shorter your context, the better the performance, at least for today's large language models. Okay, questions on the brief like intro before I move on to the code itself? All clear what's TaskGen? All right, let's move on to the exciting part. So here, in order to do TaskGen, you just first need to pip install TaskGen AI. And basically you will basically install whatever is on this GitHub. It's actually a Python package as well. So over here, when you install it, you just from TaskGen import star, which imports 3 functions: agent, function, and StrictJSON. Okay, so this import random not needed. It's only because yesterday I was trying out random number generation. So first, if you are using an OpenAI large language model, you can just key in here your API key. I have my actual key here, so I'm not going to show. So after you key in your API key, you can actually use StrictJSON already. If you have a large language model, you can just define your large language model like that, and then you can put like your system prompt and your user prompt, and basically you just return a string. Yeah, so basically the string that you return here would be similar to like how you would do this one. So I can just show you this. Like if you want to integrate your own LM, you just return whatever the large language model would output for your user prompt and system prompt. And then you have this LM here, right? So let me just copy and paste this here. So, oops. Okay, let me copy and paste this again. So I'm just telling you how to do a custom LM because I think some of y'all might want to use your own LMs. So if you want to use your own custom LM, okay, very simple. So what you do is in the agent function or StrictJSON, okay, you actually have some value. So I'm just going to show you for agents. So in agents, what you do is like, for example, I want to create an agent, right? I will do like that agent. So maybe I will do a cooking assistant. Okay, then it tells me how to cook. So this is the agent name. This is the agent description. Okay, and then over here, you can just put LM equals to custom LM. So you can replace this over here with the LM. Here I use OpenAI. Okay, you can put Llama 3, Claude. I've tested with most of the LMs and the prompt should be working. Okay, except maybe the concise models. So over here we have our agent, and then we are using this large language model here. So similarly, if you want to put the LM in StrictJSON, put the LM in the function class, it's okay. Just need to put as an additional input variable here. Very simple. So how do we use agents? So this is step 1 of using agents. We just define the name and the description. So if you look at the agent class here, we can see how the agent class looks like. Let me just go to the agent class so that you can see. So in the agent class, we have the agent name and we have the agent description. All right, we also have other stuff here that I'll be covering a bit. Max subtask means how many subtasks do you want to split until. So you might want to limit like maybe up to 4 or 5 subtasks because if not, it might take forever. Okay, memory bank, later I'll cover a bit of it. It's like how you imbue some memory inside the agent so that it can do write over this memory as needed. Shared variables is how you share your memory across functions. Global context is if you want to have even more specific prompting, you can use global context to give more information to your agent. Okay, default to LM, basically, if by default it's true, means there will be an LM given to the agent. So the agent can use a large language model to respond to anything. If you put as false, that means the agent will only use the equip functions you give it. Right? Verbose basically means whether or not you want the large language model to print out what it's doing. So like at every step, what's the outcome by default is true. Debug is if you want to print out even the details of the StrictJSON calls inside the agent. You can set to true, then you can see that. And lastly, we have the large language model here, which basically tells you what large language model to use. If you put none here, it will use OpenAI ChatGPT by default. So now I have a custom LM. How do we do it? We just run. So you all want to learn how to cook anything? And any suggestions of what you want to learn? Okay, let me just do something simple. Maybe pasta, all right? So you can just run like that. So first step, boil water. The LM will say to boil water, you need to do some amount of water in high heat, add the pasta, all right? You can say that, oh yeah, put the spoon to push down any pasta, cook until al dente. I have no idea what this is. I'm not a chef myself, so I guess this means how the state of the pasta, right? So if you drain, add sauce or seasoning. And you can see this is what we have so far. And I think that's more or less it. If you want it to do more, you can just put like num subtask equals to 10 or something. And then you can run again. Okay, I'm not going to run right now. So I just want to show you something. after we do all this, you can go to agent.status. And what this agent.status will tell you is your agent name. This is the cooking assistant. Then what you want the agent to do, like tells me to cook. And then over here, we have two functions. One is called use LLM, which means it's a default function given to all agents, where we use the large language model to generate our output. And then we also have a function called end tasks. Basically, we need a way to end the whole flow. All right. So end task, if end task is called, means that the LM has deduced that the task has completed. So you can see this is the overall task. These are the subtasks completed. Whether or not you want to boil water, add pasta, all these are different subtasks, and the large language model will generate out the thing. So what we can do is like that. We can even ask the large language model to reply a question you have using reply user. And here you can ask like, give me in cookbook format how to cook pasta. And then we can see whether it gives the right answer. So I guess this is what it looks like in cookbook, or give me in bullet point format. So this basically is like given whatever you have over here. Okay, this is the context, and then you can use this as like a QA bot to ask and get your answer. Again, you can see how this looks like if you use agent.status. You can see this questions to the agent is actually given as a subtask as well, so that next time the agent can also use what you reply as some context to deduce what to do next. So in some sense, it's like a conversational bot already. It's just not that great a conversational bot like that because there's too much stuff here. So actually I'm actually in the progress of creating a conversation class where we take away the conversation part and put them separately. But you can see that if we just use reply user, it looks like it can perform the job of a conversational bot as well. And it looks like that. Yeah. So this basically is quite cool. You can do a lot of things. And what you can do next is, if let's say you want to ask a question and you don't want this question to appear in your subtask completed. So you can see this subtask completed is essentially your memory. It's like a history of what all the all the various functions you have called, what they have done, you put in subtasks completed. And this can be referenced by future functions. This can be referenced by inner agents. Inner agents as in, if you call another agent to do a subtask, this can be referenced by the inner agent as well. So it maintains a common picture. Okay, but of course, some people tell me, like, hey, this subtask completed might be too long, right? Who here thinks that it's too long? Can you imagine that you keep doing subtasks, it will be longer and longer? Anyone here thinks that this might be too long context after a while? You all agree? Okay, you're a bit quiet. Can get some. Do you think like if you keep adding the subtasks like that, it's going to be too long? Anyone?
Yeah, I think it's a bit too long.
Yeah, correct. So actually in the agent class, I built something to do that. Okay, I just didn't make it the default, but you can actually do the summarize subtask completed. So you have this summarize subtask completed. Let me show you how this works. So what we can do here is we can do agent.summarize subtask completed. And then we can just say, we can just summarize the task itself, how to cook pasta. And this is the summary given from all our above stuff. And let's see the agent status again. And you can see now the subtask is how to cook pasta. And this is the new subtask, which is like, this is how we cook the pasta. And the task completed is true. All right, so let's try to run another task now. So we run another task. If the task is different from this task here, we will reset the task completed, which is inbuilt, so you don't have to do it. So let's say I want to say how to cook, I don't know. You want to learn how to cook something? I I have no preference. Like how to cook, maybe any suggestions? Yeah.
I've been trying to get better at cooking sausages.
Sausages,
Like yeah, bratwurst, stuff like that.
Do you have a specific sausage? How to spell it?
BRATWURST.
Bratwurst. Oh, that's the German sausage, right?
Yes, sir.
Yep. So you can see over here, we have a subtask completed, which is irrelevant here, but this might be useful if you have different tasks that link to the next task. You can actually do a summary like that, and then you can run another task here. Okay, let's see how this works now. So preheat the grill to medium heat. Oh, only can provide, yeah, so basically, they basically don't allow you to preheat the grill because this grill is not equipped as a function yet. So if you want to do an automated bot to, to do some, so over here, they identify this subtask and then they say task completed successfully. Let's take a look here, what happened. So after this, it kind of breaks the thing. Yeah, so previously they only did one step and then this step. So maybe what we can do is like that. Okay. So this is my preferred method. If you want to run a new task, do a reset. Okay, what does the reset do? Let me just show you this. If we do a reset, so I want to make this very, very friendly. Like it's going to be something like TensorFlow. You can just query the stuff using status. You can reset the whole thing. So reset preserves the agent name and description, removes the task, resets the subtask completed, sets the is task completed to false. So you are able to run the thing again. So one thing about TaskGen I find is that because of the way this subtask can influence the future tasks, if your task is totally irrelevant, it might be best to just reset before you run a new task. So let's just take a look how this looks like now. So we run this task. Okay. So surprisingly, you see preheat the grill. After we remove the summary, okay, it doesn't give me the thing saying that, oh, I can't do it. Now it gives me the thing now. It gives me the actual steps. So this again is a bit on large language models as well. What you put in your context actually affects your generation. So even the summary would affect the generation. If the summary is irrelevant, it might also affect the generation of the next task. So this is my recommendation. If you have a new task, just reset it. So the less stuff you have in subtask completed, the better. Right, so we can see this is the end outcome. We have preheat the grill or skillet. All right, place the bratwurst sausages on the grill, cook for 15 to 20 minutes, occasionally until brown or cooked through. Right, so this is how a sample agent is. Okay, chicken, you ask. If you think a subtask is a mistake or wrong, can you delete a specific subtask? Definitely. So there's this thing called remove last subtask. You can just remove that subtask of the last one. So let me just run this. So if we remove the last subtask, we remove this subtask. And when we can take a look at the status again, you can see that there's only these two subtasks. Okay, what if you want to remove something that is not the last subtask? What you can do then is you can do this agent dot subtask completed. So subtask completed is a dictionary actually. So you can actually see that this subtask completed has two keys, this one and this one. So if you want to remove the first one here manually, what you can do is you can basically say you can delete the key over here. So that's if you already know what you want to delete, you can delete this. Or I believe there's a way to also delete the dictionary by index. Okay, so you can delete this. And what you can see is that, so subtask completed is a dictionary. So you can see that we only have this left. Yeah, so some people ask me before, like, why use dictionary to do subtask completed? Why not use a list so that because right now if you use a dictionary, whenever you perform the same task again with the key, this will be overwritten. Okay, and the response to this is that I tried before as a list, and if we put as a list, sometimes the LM doesn't know how to stop. So it's a generation issue by large language models. Right now, it's a dictionary, so that I detect if the same key is generated again, I will manually stop it. So some weaker large language models, they will generate the same task again, although it's completed. So with that in mind, we will stop the subtask generation if there's a repeat of the subtask, which is a very pertinent point here. If you need to do the same action multiple times, you need to handle it in a different way. So the naive, the vanilla TaskGen architecture assumes that your subtasks are all quite different in name, so that when we detect the same subtask being done, we can stop the agentic loop. But if you have similar tasks that you need to keep doing, okay, we have methods to do it. One way is to set default to LM to false. Okay, when we set default to LM to false, I will allow repeats. So if you look over here, in this get next subtask function, if we have, okay, the default to LM to be false. Okay, where is it? Here. Okay, if default to LM is false, okay, I won't end the task if, let's say, they repeat the same step again. Because sometimes you want to operate it in like OS mode where you want to just use the large language model to map to actions. You might map to the same action again. So I catered for this like that, right? So you can just default to LM to be true. Oh, sorry, to false. Then you will be able to run the same step again. Okay, but that's not preferred. What I prefer is that every time you run an action, it's best to just clear your subtask completed so that you can start anew. Okay, as what you saw in the demonstration earlier, if we have some irrelevant information, it can also affect the generation of your task. So it's best to start afresh. And then you might ask me where to store all this information that you have generated so far. The answer is actually in shared variables or global context. You can actually take out the essences of what you have done so far and put in some global context that will be used for future runs. Okay, then in that case, we keep this subtask completed empty and free so that the agent will split the subtask better. So at least that's what I found out. Okay. So yeah, I think that answered your question, right? You can, yeah. So this is the current thing right now. So there's another thing that I wanted to share. And this thing is, okay, right now, this is my status, agent status is like that. Okay, if we want to ask the agent something, agent.reply user, you want to ask it something like, you can ask it, how long should I cook for? And you don't want this to appear in your subtask completed. You can just put stateful equals false. Okay, so you can see that cook them for 15 to 20 minutes. Let's see the status now. The agent status, although I asked this question, because I put stateful is false, it did not appear in my agent status. So this is some way to get a QA bot without putting it into subtask completed. So these are just some examples about like how to use agents without functions. Any questions before I move on to functions? Like I think what I covered is basically how to it's very easy to create an agent. Just put a name, put your description, and then you just tell what tasks you want it to run, right? And then that's it. Very, very simple. And if you want to run, okay, so there's one other thing I want to show you. So, okay, you can see here in the run, okay, in the run call, we have this num subtask again. So you can actually ask it to run for X number of steps. You don't have to run for all steps. So the agent itself, if you look at the agent function, the agent will have a default num subtask as well. Max subtask, sorry, the agent is max subtask. So if you don't define your num subtask in your run, I will default to max subtask. So this is actually max subtask. So let's try to run this again. Let me just go here. Okay, there's a lot of things that so stepping through one step at a time. You can also do this. So what we'll do is like that. We first define the agent. And then let's say cook cook something exquisite, cook omelette. Yeah, I don't think it's very exquisite, but I just want to show you like if you put num subtask is 1, what we'll do is that we'll run it for only one step. So first step is gather the ingredients. You will need eggs, butter, salt, pepper, and so on. So you can see the agent status after I do this num subtask. The agent status is not completed. It's only did one step. So let's run this again. So you can run that the same task and then it will continue the thing. So this allows you to, step through one by one. And then if let's say the subtask needs you to do something else, you might want to do an if statement and do something else and so on. So this allows more flexibility in terms of controlling your agent flow. So you can just slowly do until you complete the task. So after whisk the eggs, okay, we run again. It tells me task completed successfully, which means that I'm done. I'm done. Great job, right? We have learned how to cook. And again, we can also do the reply user step. So it's like summarize how to cook an omelette in point form. And then maybe we just put stateful equals to false. So I think quite clear how to use now, right? Like, so this is how we do it. So let me just try to throw the thing off a bit. I ask it something that is not in the context. So over here, you see gather the ingredients with the eggs. I'm going to ask it something totally different, like how many stars are there in the universe? Actually, I also don't know the answer to this. So let's just ask it. And you can see over here, in the prompt for reply user, I made it adhere to the context as much as possible. At least for most models, it can. If you're using a weaker large language model, maybe it can't. So you can see that this reply user, it will reply only whatever is here in the subtask completed. So it's quite accurate in some sense. You can try it. Let me know if it breaks for you. Actually intended to use this as a like query to, if the user wants to talk to the agent and find out what the agent has done, they can just use the reply user and find out. So this actually allows you to talk to your agent to find out what the agent has done, what the agent has learned. You can query. If you have summarized your documents, you can query your documents like that as well. If your documents that you extracted is in subtask completed, you can do that. Okay, questions before I move on to functions? Or any comments that you all have so far? Oh, good. I pause here for a while. So if good, you just give me a thumbs up. If not, you can ask something before I move on to the functions part. Okay, so let's move on to functions. So I hope this is interesting for you all. So you can play around with this, do whatever you want over here. So I just do cooking because I like to eat food, and sounds nice to demonstrate this. Now what I will show you, okay, why did I screw up? Now what I want to show you is how to assign functions. So in TaskGen, or actually in StrictJSON also, okay, so what's the difference between TaskGen and StrictJSON? So let me just write here. TaskGen is for agentic flow, where you don't know what function to call. StrictJSON is StrictJSON as in the StrictJSON function, is when you already know what you want to do in the pipeline, and then you just define inputs and outputs. Okay, so actually this is not agents and functions. This is actually just a subsection here. Let me just write here. When to use StrictJSON versus TaskGen. Okay, let me just put here. All right, so let me just demonstrate this to you. So let's say you have StrictJSON, and we basically do the cooking assistant again. So like describe how to cook an omelette in point form. This will be my StrictJSON takes in a system prompt. So this is the system prompt. And then the user prompt would be nothing in this case. And then we have an output format. So the output format will be details of how to cook in bullet form. And then over here is the details. So you can specify what you want. You can also put an array and so on. So over here, let's just run this StrictJSON prompt. And you can see this is the thing that we have. So maybe if I just put this as results, and then I can print results. So we have this 1, 2, 3, 4, 5, 6, 7, 8. So this is basically going to be like similar to what you have over here in the cooking assistant. When you cook like that one by one, it tells you the task. Here is you already know what you need to do. Then you can use StrictJSON directly to do this. And this is my recommended approach. If your task or your process, you already know what you need to do, just use StrictJSON, because you incur a lot of overheads by using an agentic framework like TaskGen that helps to map to different functions. Because if you already know what function you need to map to, why do you need a planner to help you map, right? You can just map directly here. So TaskGen is used when you don't know at runtime what you need to map it to, because the user query might be very diverse. Then you can use TaskGen to do it. StrictJSON is if you already know the function. Okay, all clear with that? Because I think this affects a lot of like production stuff. You should use StrictJSON as much as possible to minimize overheads. Because StrictJSON is more efficient than TaskGen in the sense TaskGen there's a lot of additional features to help to map functions and so on. Okay, so now we talk about functions, and functions are very important. So functions are like, if you talk about LangChain, they are your tools, all right, your LangChain tools. AutoGen, there's also functions as well. So whatever your agent interfaces with is actually, whatever that's external to the large language model can be a function. And functions, there are two kinds in TaskGen. So the first kind of function is a StrictJSON function like this. So, one way to do this StrictJSON function is like, you can do it like that. You can define my function is like that. And then, inside this function, you can say this is StrictJSON. All right. You can just return this. All right. So this is one way to do it. Okay. This is the longer way. You could define a function like that. Okay. This is an external function that you can use to call your StrictJSON. Okay. But the shorter way is like this. If let's say you are using a StrictJSON function, what you need to do is just call function. Function takes in a few parameters. So if you just go to function here, okay, there we go. Function takes in your function description, your output format. Actually, that's the main thing. Okay, external function is if you want to interface with external functions. Function name is if you want to call the function a name, which you should. I mean, if it's external function, we just use the external function name, or you can just define a function name if you are using a StrictJSON function. If you don't define a function name, we will use StrictJSON to generate the name for you based on your description. I show you. So I'll put a function name to summarize the usage of this function. It's very cool. I coded this out. So you don't have to give a function name. We will infer it for you if you don't provide this. Is compulsory is later if you use memory. Is compulsory will bypass the retrieval augmented generation across functions. You will always use that function if you put is compulsory is true in your planner. So just to take note, this function is used as a very important class to give important and useful functions to your agent. So let's take a look at how we do this function call using StrictJSON. So this is why I call an internal function. Okay, because we just use StrictJSON to do this. So how do we do this? Describe how to cook dish in point form. So we have a function description. We have the output format. So the output format could be, we can just copy here. And we can call this function like cooking function. Okay, maybe we give it a function name also. Like, okay, maybe I don't give a function name. I'll just show you how we name this. So what you do is you describe how to cook dish. So dish is your variable. So it could be like that, dish. Describe how to cook dish. So essentially, this is what it's doing. So when you put angle brackets here, it tells the function that this is an input variable, and this input variable must be taken from the user, or it must be taken from the agent. So you can see this is how we do the dish over here, how to cook a dish in point form. So we can also do this same function using this external function method. I'll show you how to do it. But if you are using a StrictJSON function, you can just call function like that, describe your function here, and put all the input variables in angle brackets. And you know what? You can also put your type here. If you put your type as string, int, float, list, dictionary, basically the supported types of StrictJSON, we will do type checking for you before we call the function to ensure that the input variable is of that type that you have defined here. So if you put your type checking here, you can ensure that. If you don't want to do type checking, you can just also put a description, a delicious dish or something like that. So so that if you use a large language model to generate your input to this function, the large language model has more context about how to do this, what kind of input you want. But let's just use type checking here. So let's call this, and let's take a look at what cooking function is. So cooking function is just a TaskGen function. And how do we see what this is? We can just print out. And you can see this is the description of your function. Describe how to cook this dish in angle brackets in point form. Input variable is this dish, and the output variable is details of how to cook this in bullet point. So it's like that. So you can see it's very, very concise compared to, let me just show you that thing again, compared to this. So if you look at this is so lengthy, right? If you use OpenAI function calling, it's going to be very lengthy. If you use TaskGen, less than half the tokens. Yeah, so this is the strength of it. And putting these angle brackets as the input saves you to write the input tokens as well. And LMs understand these angle brackets very well. I've tried various forms. These angle brackets work very well. LMs know how to substitute the angle brackets, mainly because maybe it's HTML or something. Yeah, they know how to substitute stuff inside here. So this is how we do the cooking function. How do we use this function? Okay. We can just call like that, cooking function. And then you say, maybe let's say omelette, okay, because we have seen how to cook the omelette. So to use the function, this is how to use the function. This is how to visualize the function. So we can also use, how can I have this? We can also use this cooking function for other stuff. So you can see that, like, let's say I want sausages. And then you can see this is the how to cook it. So whatever we done with the TaskGen agent right now, if you already know that you just want to get the cook stuff in bullet point, don't do what I showed you just now. This one is if you want to do very arbitrary stuff, you can do like that. But if you already know your use case will need to generate how to put something in bullet points, just use StrictJSON and then just use this function here. Ta-da, done. So let me just spend some moment to appreciate the beauty of this. In traditional coding dogma, you have to code out the function for the input-output relation yourself. You need to write everything like this in the code. And this one is not StrictJSON. This one is going to be some rule-based code. You use some algorithm. Maybe if you are doing this cooking, you search the web and then you give the answer back. Yeah, it's going to be a very lengthy function. But with the large language model era, you can just do this whole thing as a large language model function, especially if you don't need accuracy here. I mean, if it's something like creative generation, just use a function. Yeah. Just a quick point here though, like large language models are great for some stuff, but not great for others. Some stuff are like creative generation, doing some flexible matching here and there. And not so good stuff is logical stuff, math, law, maybe medicine. If you want very, very logical or very domain specific, large language models may not be your answer. Also, if you need it to adhere to certain formats, large language models are not that great at adhering to like certain rules also. So if you can, in your function here, you can also potentially include some rule-based processing. Yeah, it can be pre-processing. So this is rule-based pre-processing. You can do it here. So like, for example, if you already have a list of dish that you want, okay, let me just show you how this is done. So we have this result is like that. So you call the LM and then potentially include some rule-based post-processing. So you can do like that to make the output more reliable. So in the end, we just return like rest. So what we can do is maybe we just replace we replace us like if you want to change like a /n with maybe a /n/n, you want to make the things longer. Yeah, maybe you can do it here. Over here, what you can do is you can just dish.split. You can split the dish by basically a space. So like if let's say your dish is omelette with fried rice, maybe you just only want the first letter. So yeah, so we can do something like that. So basically, if you want to do something that involves some rules that you don't need the large language model to do, my guideline is to put the rules inside the function. All right, you can do the pre-processing here, you can do the post-processing here. This will help a lot because we then restrict the amount of stuff the large language model needs to do, and it gets better generation. So this is how we potentially can define a function. Let's do this. Okay, so this is an external function. All right, how do we do the external function inside here? Okay, so this is for external functions. So it's for internal functions. Okay, so we have a function here. Let's not call it my func because if in the large language model era, your function name actually matters for semantic matching. Let's call it cooking function. All right. And how we do this for function itself? Okay. Anyone who has used TaskGen before want to tell me how to interface external functions with the function command? Brian, what's the input variable for external functions?
I have to look at my code.
Okay, no worries. So the input variable is this. External function is this. So you just need to say, okay, this is my external function. All right. Then basically before that, you can give the function description and so on. No difference. You can give the function description like that, like saying we can just take the same stuff here. So the function description, the output format, all the same. And here you interface with an external function here. So we can call this cooking function again. All right. Cooking function external. All right. Let's take a look at cooking function external. It's a TaskGen function. Let's print this out. And there you go. You see, this is how we get it. And we can also do the same thing. We can run the cooking function external with omelette. And you can run with oh, sorry, dictionary has no attribute replace. This is my bad. I called for replace in the dictionary when I should be actually calling res yeah, so we can actually call we can replace the output of this. Yeah, let's do this again. So over here we have how to cook omelette in bullet form. Here let's try sausages. So you notice something, everything here is /n now, right? It's because we have done some post-processing here to replace this. So the benefit of external functions is that even if you use like StrictJSON inside it, you can do a bit of rule-based processing inside these external functions as well. It makes it very, very flexible. You can combine both benefits of rule-based approaches and LM-generated approaches all in one in this external function, just like that. All right? And the function looks exactly the same as this. So there's something that I need to show you. Here they did not have the name, but let's just take a look at the function name. You can just do it like that. This is cook dish in point form. Nice. We have just generated a name for this function based on this description. How cool is that, right? Like just the description, you can come up with a function name, right? Let's take a look at cooking function external, the function name. And it's cooking function. I mean, nothing surprising here because I will just base it. We will just base it on the external function's original name in order to decide like what's the name of this function. So this is how we interface with internal and external functions. But that's not all. Okay, what I just described to you is just how to define the function. Okay, I haven't showed you how to equip the functions to your agent. Are you ready for the revolution now? Are you ready to see the revolution? So now we will do equip the functions with your agent. So earlier on, you saw that we have a cooking agent, right? That only knows how to cook. Let's make the agent even better. Let's call a new agent, okay? Agent better, okay? Maybe call it better, maybe just call agent 2, right? Okay, you can call this personal assistant. All right, it just helps user do stuff. Okay, so this is very, 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 very big. All right, so this agent 2 is our new agent. And I mean, you can just try like agent2.run, like schedule an appointment at 10 p.m. Okay, so this probably won't work too well because we haven't interfaced with our scheduler yet. So you want to schedule stuff, you need to see over here. LM is trying to do stuff like check for availability at this 10 p.m. slot. But you don't have a function to do this yet. So we can create a function for that. And we can also create this cooking function. So let's do that. We create a new function. So schedule function equals to. So what we can do is, for now, let's just use a StrictJSON function. Schedules an appointment at time, all right? And then what you'll do is the output format will be like this. Oh, sorry, output format will be scheduled time slots, list of time slots that are booked. So basically what this does is that we will just take in the time of the scheduled set appointment from start time to end time. So this is not a rule-based function. This is just basically using the large language model to interpret what this start time and end time is. It would be better if we do something like this to, do a rule-based check to see whether your calendar is occupied, then fill in. But, just for the sake of time, I'm just going to use a StrictJSON function to do this like that. Just like that, we can have a schedule function. All right, let's take a look at agent 2 status. This agent 2 status, right now we have this subtask completed. No worries. We're gonna reset it anyway, so don't worry about all this. I mean, let's just reset it now anyway. Yeah, so you can see this is the status of your agent 2 right now. Now we're gonna do some magic. All right, we're gonna equip the functions that we have implemented. Over here we have a scheduler, and up here we have a sausage cooker or like a food cooker. Let's do that. Let's integrate this. So what we do for integration, agent 2 dot, okay, assign functions. And you just put the list of functions here, or just put the function itself. So we assign the cooking function, and we assign the schedule function. Ooh, let's take a look at the agent status now. So after you assign the functions, so this is, right now we have use LM, end task, cook dish in point form, and schedule appointment. So you can see that all these are the functions that your agent has. Let's take a look at all the functions and their descriptions. So you can use this command called print functions. And print functions will basically list out the names of your function, your description of the function, what inputs it takes, and what outputs it takes, and what output it gives. So all these are very important for the large language model, because the large language model will be given all this information here, and this will be used to generate the plan. So like all these outputs are important. Also, you need to specify outputs well. That's why you have to give the output here. This is something that is not really done in other agentic frameworks. I think this output is very, very important, because how your output comes out is going to affect how the next part of the plan works. So you can see that this is like how we do it. And this is basically your personal assistant with the cook dish in point form and the schedule appointment. So let's take a look, shall we? Shall we take a look at how this can be done? And if you look here, this is my print functions, and these are all the functions that I have. Now, let us run this and see whether, schedule a 1 hour appointment. let's run this. Okay, so I should reset agent 2 actually. So let's run this and see what it gives. Okay, so right now we don't have a check schedule. So all right, let's create a check schedule function. All right, so so over here maybe we need to have shared variables because our time slot needs to this should be a shared variable actually. So check schedule. Okay, maybe we don't need a check schedule function. What we will need is maybe we just like, because I don't have the shared variables now, so I'm just going to say current schedule. It's 3 to 4 p.m. is TaskGen tutorial, maybe. Yeah. So maybe we do something like that. This would be better handled by shared variables and global context. Okay, but just to show you how this works for now, let's just okay, so now the agent has access to this in the context. This is my current schedule. So no available time slots for 10 p.m. Okay. So they basically said that find available time slots at 10 p.m. They got the LM to do it. They did not get the schedule appointment function to do it. So what it can be done is that over here in the schedules and appointment from start time to end time. So you got the LM to do this. I don't want that to happen. So I'm going to set default to LM to be false. So what this means is that I don't have the large language model anymore to this agent. Okay, it will have no choice but to use whatever functions I have given it to do the stuff. Right, so let's try to do this. Schedule a 1 hour appointment at 10 p.m. See whether it calls the right function. So it calls the start time 10 p.m. end time 11 p.m. and this is my scheduled time slots. Great work. And so let's see whether it knows how to end it. Okay, so you see, this is the problem for like large language models. They actually they don't know that this is completed already. So right now, what we need to do, okay, this is a very good example actually. So once we have this scheduled time slots, maybe what we can do is we should also add like completed status, completed or not completed. Maybe you should add in a completed status here so that we can tell the user that the time slots is done. So whatever your function outputs will go into your subtask completed. So this is important. I mean, you can even put like this type enum, okay, completed, not completed. So with this, let's run this again. If the agent sees this in subtask completed, that is completed. How come I don't have this? Wait, wrong. So what we need to do is, okay, we need to do an output here. So let's run schedule function again. So schedule function, maybe we just do 10 p.m. to 11 p.m. Now there we go. Status is not completed. So what we need to do is, let's just run the whole thing again. I just want to make sure that there's a completed status here. Okay, let's run this now. Completed status not completed. Okay, it thinks that it's not booked yet. It just thinks that this is the scheduled time slots. So again, this naming time slots, yeah, we can just say that these are the booked time slots. Completed if time slot is booked, otherwise not completed. List of time slots and event. Okay, let's just try something like that. Yeah. So this is all live. I mean, I didn't really try it out before that. So you can see how your prompting actually affects this. There we go. We have scheduled this appointment. Completed status is completed. Okay. Again, here it seems that they still continue to. So this is what I mean by the LM can like potentially hallucinate, can do different things, but actually all doing the same stuff. So what we can do is usually for this kind of personal assistant, if you only have one task that you need to do, yeah, you can just basically do this. So it will just do only that task. Yeah, there we go. So that's how we get the scheduler. So if let's say we want to do something like, now I want to do like, cook me an omelette. And this will potentially match to the omelette function. So let's take a look. And this is how we do it. So we have equipped our personal assistant with two things. One is a scheduler and one is a cook and omelette. Let's see whether we can do even more cool stuff. So let's just put num subtask as 2. Find out, or basically, I need to attend a cooking class to cook an omelette at 2 p.m. A 1-hour cooking class. Help me, basically like that. Let's see whether it's big enough. This can run. So, oops. So this is apparently not that great. Like you see, it returned nothing. Help me do the necessary steps. I need to attend 1-hour cooking for cooking. Yeah. So ChatGPT needs to be prompted a bit like and how to do. They don't do this natively. So over here, ends from 2 to 3, correct? It has done this. Follow the step to cook the omelette in the class. So just doing this help me do the necessary steps was needed for alignment, because like just doing this alone, it did not manage to match the functions. So this is basically how we can do it. And then you can even ask your assistant like this, like, do I have a free slots at 4 p.m. to 5 p.m.? And then you can put like stateful equals to false. So you could do something like that. Yes, you have a free slot at this. So you can ask it like, do I have a free slot at 2 p.m. to 5 p.m. today? Okay. Yes, you have a free slot as the cooking appointment is already booked at that time. So it seems to think that, do I have a free slot? That means that, this doesn't make sense, right? Like, yeah, that's why I say like large language models, they are not that great, like even for a reasoning class. So we can say like, do I have any appointments? If you use GPT-4, this is not a problem. Yeah, so you can see here. Do I have any appointments at 4 p.m. to 5 p.m. today? No. So this is a simple guide of how to make like a personal assistant using 2 functions. We can do more and more functions, and basically you can see over here this agent description. You can put in stuff like this, like your schedule, in order to make the agent know more context. And yeah, I think I'm just going to leave it at this for the equip functions part. Any questions that you all have so far? Or anything you want to see for these functions before I move on to shared variables?
I have a question. So actually, I've been playing around with the functions a lot, and I realized that this subtask the hallucination happens quite very often. So if that's the case, why don't I just change all subtasks to 1? Then I just have multiple agents that just only just be that one function.
So that's indeed the case. So in fact, I'm moving TaskGen to the global context approach, where after you schedule all this appointment, all these book time slots will be in your global context, and then you just keep running the task one step at a time with the global context. It seems to work much better. So indeed, I think I'm moving towards that, because LMs, when asked to create the next subtask, they might hallucinate to do the task again. But if you put it as global context, it seems to understand the word global context quite well. Or at least if you put in the description, you also understands that this is what is there so far. You can condition on this to generate your task. So to answer your question, Brian, I am moving towards there. I think global context is the way to go actually, so that we minimize just now what you saw, they do the same step again and again. And we minimize that by having in external context.
Okay. Then that's cool. Yeah, because I find the meta agent is much more accurate until it starts to call inner agent to do things, because it will call like normal agents correctly. But yeah, anyways, all right.
No, that's a very important point. Like, so all these concepts of TaskGen right now, they are only a few months old. We still have to test it rigorously. So far, it's working for the examples that I tried out. But as we scale up more and more, we might need more and more architectures to make it more performant. So I think global context was created for that purpose. And eventually, maybe we use global context for everything. So this is just an example of how a vanilla approach would do it for functions. To do this approach, you will need to prompt it very extensively to make sure that the LM understands, like over here, this completed and so on. So you see, even the workbook and schedule, there's a difference. Like if you put scheduled time slots, the LM might think that you're still free, at least for ChatGPT. So stuff like this still matters a lot. I'm just going to show you one last thing before I move to shared variables. Is called function calling. So OpenAI function calling, you can also do something similar to that with your agents, and you can do that using use function. So you use function you can use with a task. So for example, your task is schedule badminton session at 3 to 4 p.m. Right? And then over here we can just put stateful equals to false because we don't want to update the shared memory. Okay, maybe I don't put stateful first. I show you what this does. Oh, sorry. Select function. So what is select function? Select function will basically tell you what function you should use and what are your parameters. So if you look at okay, so select function won't update the state. Okay, so if you look here, what we can do is we can do function name and function params. Okay, so what we can do is that we can use this agent2.use function, function name and function params. So essentially you can have your function calling with TaskGen. You just need to put all the functions you have inside this agent and then you can just say select function, select for whatever task you want to do, and then you can see what's your function here, you can use it. So if you want to do a step-by-step like mapping a task to a function, you can just do this select function directly. And you can just use the functions like that. That easy, all right? And you can see if we have done this, we have book a time slot here. Okay, and this subtask here has no name because we did not give it a name. I mean, if you use the use function, you can give a subtask name here also. So this is how you use the function. Usually when you do something like that, you can also give your own subtask name. Okay, so you can just say like your subtask name is I call it subtask name in this? Subtask, it's just subtask. Call it subtask. So this allows for more like you can just put the same thing here for more fine-grained stuff. So you can see schedule badminton session at 3 to 4 p.m. and then this is your time slot. So this is essentially how to run the function step by step. Okay, and you can do this so that you have full control over what function you want to use. You have full control over the parameters if you want to change them. Okay, but essentially, I don't think you need to do this. This is just if you need to, if you want fine-grained control over what your function takes in. and what you use and what parameters you want for it. And this is generally not needed, because TaskGen would do it for you. If you just do this num subtask equals to 1 or something, you would see that TaskGen can actually do this for you. Okay, you don't have to run this whole thing yourself like that. Okay, so this is more or less function calling. You can use the function with stateful equals to true, false. Okay, and this means that if you schedule, let's say I schedule a badminton session at 2 to 3 p.m. can see that this wouldn't appear inside here. Okay, this wouldn't appear here because I put stateful false. Okay, so it won't appear in your subtask completed. So in general, subtask completed is like your sketch pad of what has been done and so on. And in general, my guideline is to make the sketch pad as empty as possible, so that it minimizes hallucinations and so on. And it's best to put everything in shared variables or global context, so that whatever you have done here so far, like all these book time slots, all this can actually appear inside your agent description, or if you have global context, it can appear in the global context, so that the agent will have all this information, but your subtask completed is empty. This makes your agent perform very well. Okay, global context. Okay, so let's move on to memory. Okay, I think memory, maybe I don't cover it today. I'll do shared variables first. Because memory is like, it will take quite long to cover. So shared variables, let's just use the same thing here again. So let's call it agent 3 now. All right, agent 3, and we have this schedule function. I don't need to copy. I can just put here. So you have seen earlier that I have done this here inside. Basically, the like this current schedule is done in the system message itself. But what if I want to do, okay, maybe I need to copy the schedule function also. What if I want to do shared variables? So shared variables allows you to store information in external variables. Okay, and this can be used by your functions and so on. So this is actually a shared variable here. And what this means is that I kind of want to make this book time slot here. Like the output here should go into shared variables. Okay, so there are two ways to do it. One way is to use the function here. You just call it as something. So as book time slots will mean that this is a shared variables output. Okay, and over here, let me just show you how this is done. So if I just put this as book time slots here, this will go into the shared variables as book time slot. And how to get shared variables is like this. So shared variables is a dictionary. And then we can just call it as book time slots here. So when the output here gets from the as book time slots, you already know that this will be from here. You can also say taking into consideration as book time slots. So this references, okay, this is schedule function shared variable. So this schedules an appointment taking into account the as book time slots. Okay, so this shared variables, the book time slots right now, we should have it empty, right? And basically then it will be a type array, right? Okay, let's have this. So I have a shared variables now, and let's take a look at the agent tree. We have end task, cook dish and point form, and schedule. Oh, we should remove this. Okay, so yeah, this is my current time slot. All right, and if we want to, we can also see the agent print functions. You can print the function here. You can see that these are the things, and you can see that the input itself doesn't have S book time slots, because in the code itself, if you have named your shared variable starting with S, whenever you do a function for internal LLMs, we will not consider this as what is required from the planner or the LLM planner, because this will come from the shared variables directly. You don't need the LLM to generate this. And you see the output here, output has this S book time slots, okay, and completed status. But later, once we run the code, you will see that this output is not going to go to shared memory, because this will go directly into shared variables. Okay, which means that this completed status needs to convey the message that this is done, right? Why did we have shared variables? It's because shared variables allow you to process stuff that are very lengthy. Like you want to summarize a 10,000 word book. You don't want your 10,000 word book to appear in your input variables, nor do you want it to appear in your output variables. So you can do this S over here, okay, in order to minimize. So it begins with S for internal LLM functions. So if you want to use internal LLM functions, you use S here, and then this helps to deal with lengthy text or multimodal inputs. Okay, so shared variables are meant to do that. And yeah, let's take a look at how this works. So first, let's just reset, and then let's run book a badminton session, book a 3-hour badminton session, starting from 2 p.m. Let's just run this and see how it goes. And oh, let's take a look. Output field is not one of this. So what did the output field come up with? None. Find a badminton court for booking. Okay, so basically, it doesn't know, like, it needs to use this schedule appointment. So again, you see, this is where you might need to change your words a bit. So again, the semantic match between the task and the function is very important. So there's one way to help to do something like that without changing the words too much, and that is using memory. Okay, so you can actually put some memory of like how to put this input tasks to your equip functions. You can do a mapping. Okay, I'm not going to go through that today because that's a bit complicated and that deserves a separate session altogether. But yeah, you can see that this is how flimsy the matching can be with like ChatGPT. It's much better with GPT-4. But you see, you need to match your words directly like that, 2 to 5, and it's not completed. So over here, why is there a problem? The problem is that we have the thing called not completed. And why is that so? Okay, let's take a look at the shared variables. We have this, but we have not updated our time slot here. Okay, so let's see why, all right? Update, maybe you should say update the S book time slots. Right, let's try this again and see whether this works. So this works and it's completed. So you see, just a phrasing change because now I'm using a StrictJSON function, just a phrasing change to update it rather than just to list out. Because list out, what it does is just repeats what it has in the memory and just repeats again. But if I update it, you can see my shared variables now has this 2 to 5 p.m. Okay, but it failed to update in the right format. So what we can do, update in the format of time event. Yeah, so let's try to do that. And let's see whether the magic happens. And output field is not of type array. Okay, so it basically okay, I get what's happening. So it basically thinks that it should be okay, it basically didn't come out with an array, not a problem. We just need to prompt it better. So again, a lot of it has to do with prompting, unfortunately, because it's a large language model. So over here, let's see what happens now. Okay, I get what to do now. It's not natively doing this. So what we should do is need to be a bit more explicit if you want to use array. Let's try again. So it's good that all these errors are happening so that I can show you like how to fix it with some prompting. So just by prompting it a bit more specific. In fact, if you just name this time slots array, all right, it helps a lot with, if you put array in your name here, you don't even need this. Okay, the large language model will understand. So in good practice, if you want to have an array as an output, you name array in your input variables. Okay, let's see whether it runs now. Okay, so that wasn't enough, not a data type array. So guess what? I still need to put this in. So this is live, how to prompt it so that it can work. So agents as of now are a little more flimsy in the sense that they don't work for very, very arbitrary prompts. If you want to match it from the input to the output, you need to describe your functions well, especially for ChatGPT. You need to give it the right format, maybe just prompt it a little bit more if needed. All this will be much better if you use GPT-4 Turbo. But as of now, GPT-4 Turbo is very slow. So if you want an agent to work right now, you just got to prompt it in a more specific way. Okay, no choice. You have no choice. I don't think there's any way to solve this right now. So you can see this is what we have. And how come we have meeting with client now? They hallucinated this, is it? Oh, since when did I have a meeting with client? Okay, let's try again. Okay, let's try again. Okay, done, completed. So you can see it's just completed. It doesn't show the booking time slot. You see over here, they come out with the, okay, so over here, you see, once it has done the first one, it failed to end for the second one. So again, this is a matter of the agent not being able to understand like more complex stuff like this. So you just put num subtask is one. In general, it would be better. So again, you see now the problem is it gives team briefing here instead. So you know what we can do here? We can just say do not hallucinate somewhere. All right. And then this sometimes can work. So let's see whether this works. Yeah, so Brian, you mentioned maybe something like this is better with StrictJSON. I find shared variables better for sharing details between tasks. Yeah, so shared variables, yes, it's sharing details between tasks. Here, I want to share the book time slot array, you see. So over here, you see meeting client team meeting, that's not what I want. So this, you know what this means? It means that actually using LM to do scheduling is maybe not the right approach. We should use a rule-based function. Okay, this is what this is telling me. Okay, maybe let me just try one more time. After that, I'll use a rule-based function and show you how this is done in a rule-based manner. Okay, let's try again. Okay, looks good, looks good. Oh man, see, still hallucinating this team meeting here. Why is it hallucinating a team meeting? I have no idea. Yeah. So this means that this shared variable here as a function is perhaps not the right way to do it. Perhaps not the right way to do it. Let's try to do it as okay, so this didn't work out too well. Okay. So I mean maybe one way to do it is like I don't call it an array. I just allow it to update this as and when it likes. Okay. Okay, let's try one last time. Okay, one last time before we give up on this. One last time. So at least it's getting this out. But you see the completed status is not completed. So yeah, annoying. Yeah. So this is where we get to right now. So perhaps it is better doing scheduling with rule-based functions. So let's try it. So I have this again. If we are doing rule-based functions, we don't need the S, okay? The S is only for strict JSON functions, which is not recommended, okay? So initially I did something like this because I wanted convenience, but I think that doing it by actual functions is actually better. So like this, doing it by external rule-based functions like this. Okay, we have defined like that. And what we can do is we can say that, all right, this one, we keep it here. Like basically we can keep this whole thing here. So over here, we can call it like schedule function 2 or something. Let's just call it like that. This is my function description. This is my function output. Okay. And over here, we can just put external function equals to this. Okay, and what do we do in this function here? We basically have a start time, end time. Okay. And we don't even need this. We just need a shared variables here. Okay, so when you put a shared variables here, immediately we will get the thing in as shared variables here. So what we can do is like that. Start time, end time, schedules, and appointment. So I have a appointment here. So what I do is like this. Okay. I just basically do in this book time slots. Okay. Dot append. I just append this. Okay. For now, I just append everything. So I append start time to end time. And I put the appointment here. So basically, I just do a simple append to the shared variables. And then I just return. You don't even need this anymore. You just need completed status. Return completed. They're always completed. All right. So we always book it. All right. So, all right. Type not done for external functions. So you don't need this anymore. And put this assign functions now into your agents. And then we see the status right now. This is the two things that we have for the agent to do. Agent 3.print functions. You can see there's 3 functions right now. And now we have appointment, start time, end time. So basically, I'm just going to print complete. And I'm just going to print that this is the appointment itself. Let's take a look and see whether this works now. So, right. All right, task completed successfully. Let's take a look at the shared variables. Okay, so it looks like they did not manage to schedule anything. So okay, that's interesting. So maybe because of the naming of this function. So schedule with time and appointment. Maybe we need to be a bit more explicit here in terms of our naming. So I'm just showing you how to debug this. Okay, so the agentic framework, a lot of things have to do with the naming of the functions. Let's take a look whether this works. Okay, invalid JSON format, schedule this. It's not one of n tasks. If not possible to output n tasks. Okay, so right now they don't have this completed. So what you see over here, the overall plan is find a Super Bowl badminton court, book the 3 hours and gather. So they have a lot more things than what the function provides. That's why it's failing. Okay. Okay, for now, we try this, okay? Now it schedules, okay, but now there's an error. Book time slots is not there. Aha! Because this is underscore time slots. So it's very sensitive to naming, and let's see. So a lot of prompting required. Unfortunately, I'm trying to make this process a bit smoother, but just bear with it right now. You can see over here. Ta-da! We are done. So we finally use this to schedule something. So now stuff like this is hard. You see, earlier on when we do cooking stuff, because it's more free form, there's no constraints here and there. It's very easy to do that. But if you do scheduler, you need to schedule in a certain format and so on. This will be a little tougher for the LM. Okay. But if you use a rule-based function like that, you can get the LM to give you what's your appointment, start time, end time. You can update this. You see, over here, calls with badminton session, start time 2 p.m., end time 5 p.m. All right. And then we can also use a rule-based method to check, whether or not it conflicts. So what we can do here, maybe I just show you how it's done. So you can just use the StrictJSON. Okay. Check whether actually StrictJSON is not the answer for this. You need to basically do a rule-based approach to see whether or not the start time and end time falls within any of these slots here. Okay, so I'm not going to show you how to do this here, but the idea is you need to use a rule-based approach. Check your existing calendar, make sure that there's no conflict with this new appointment, and then you return completed and not completed accordingly. If there's no conflict with existing appointments, then update calendar. Okay. Otherwise you return fail. So this is what you need to do. And basically this is how we do the scheduling. So as what Brian mentioned, like the num subtasks, if you do more than one, sometimes it doesn't do that great. So let me spend the last 5 minutes on global context before we end this. So with all these limitations that are discovered with TaskGen, based on how well the LM can do planning, which doesn't do very well, by the way. LMs don't do planning very well. I've come up with the latest and greatest fix to all this, which is global context. And so maybe I just spend a little time talking about global context because I think everyone should use global context because it's the best. It works the best. So what we do here is like that. We have a shared variables. So global context is like this. You have a global context in your agent that is given like this. Let's go here. Okay. So the global context takes in an agent and then gives some stuff to the agent. So over here, what we can do is we can say that book time slots will be this agent.shared variables, book time slots. And all this we can take away. So if you want to do rag and stuff like that to augment your context, you can also do it in global context. You can do a rag process and then you can put the outcome of your rag here. So at every time step that the agent plans, the agent will have access to this global context. So over here, we just need to say agent for dot get global context is this. So this is everything else that has been done. Okay, I'm just going to do the same stuff for here, assign all your functions. Okay, and then we can see the status of the agents. See the functions. These are the functions right now. And what I'm going to do now is I'm going to run. Okay, I'm going to run the same thing again. So you can see over here, I need to do, sorry, in this function itself, I just appended this, not a problem. Okay, you can see with the global context, what will happen is, let's just remove away this line here. Okay, before that, let's see whether it works. So I have given the agent some global context. So you can see that this is shared variables book time slot. This is the task and it's completed. Let's take a look at the shared variables. And done, it's done here. So with global context, okay, which means that at every call of the planner, every call of the LM generator and so on, this global context will be given. I mean, you can take a look at here. You can see where the get global context is done. So whenever you query the LM, we'll give the context. So whenever the LM needs to make a planning move, needs to output something to you, there will always be a global context. So this is using getNext subtask and use LM, allows for persistent agent states to be added to the prompt. So if you're going to use TaskGen for serious use, I recommend using global context, because as you saw earlier, if you just do simple task generation, sometimes it repeats the same task again when you put in subtask completed. But if you put in global context, the agent seems to know how to do better. So let me show you how. So this is right now 3-hour badminton session starting from 2 p.m., right? Let's say I do starting from 10 a.m. So I think right now what is happening is because there's a conflict, is trying to see how to do it. Let's take a look what happens after this. Okay, taking a while. Let's run again. So 10 a.m. start end at 1 p.m. and you can see that the scheduled session is like this. Okay, I forgot to reset the shared variables. Let's just reset this again. Okay, so what I should do is like that. Do not schedule if there is a conflict. Right, let's see whether it works. So it has the, so earlier on in agent 3, we don't have the, the global context, but now with the global context, you can see it knows that there's a conflict and it just scheduled the badminton after TaskGen tutorial. So do not schedule if there's a conflict and instead end tasks. Okay, so let me just reset my shared variables again. And you can see this is the most performant agent. By giving it as global context, okay, check for schedule, appointment back. Okay, so it still shifted my badminton session. So what I should do is you need to define a bit more of what you want the scheduler to do. So do not schedule if there's a conflict, and do not shift any sessions. Okay, let's try it. After this, I want to take away the num subtask is 1. I see whether global context can actually help it to already avoid the subtask problem. So let's see whether it works first. Yeah, so while it's working, actually, if you have any suggestions on how to improve this, I'm very open to take suggestions and improve this framework. I think it's a promising start. It's definitely not the end yet. There's still quite a bit of improvements that need to be made. But you see over here, it still shifted the. Okay, so if there is a conflict with existing schedule, do not do anything. Okay, let's just try this again one last time before we call it a day for today. So yeah, I still think global context is still the most useful. You put the global context with whatever you want, the states that you want. So the earlier subtasks you have, if you can map it to some shared variables that can be put in this global context that will appear in the agent's prompt, essentially you will overcome some problems that the subtask keeps repeating and so on. So let's take a look at this. So now it schedules at 10 to 1. Oh man, yeah, the LM doesn't understand too well about like this timing one. So, if you want to use it for rule-based stuff, maybe you don't do this. But let's
Maybe
just, yep.
maybe you can try putting if there is a conflict in the under help user do stuff at the agent.
Okay, so that's one way we can put this conflict in the agent itself. Okay, so one way I can think of is like this. Okay. okay. Something like that. Yeah, you can put so you see, this is right now we have the subtask here, check for existing schedule conflicts. Okay, so the agent wants to check for something, but there's no such function, so it still takes the schedule retirement. So if you see something like this, what needs to be done is like this: create a function that enables the LM to know whether there's a conflict or not. Then that function can be a rule-based function. So that you see, now with global with global variables, can you just see that I don't even need to do the only use function. You can see that with global variables, essentially, they already know what needs to be done. You see, I don't even need to prompt this task much anymore with global context. So global context really is quite useful. Let's try with this. So this failures, all these are expected because scheduling is a hard use case. It's hard for large language models. It's not a free flow generation. Look at that. Yeah. Okay, so one last thing. Okay, I'm just going to show you how GPT-4 Turbo does on this task. So that was ChatGPT. In general, I find like Llama 3 works better with TaskGen as well compared to ChatGPT. Let's just try running this same prompt, nothing changed. Okay. Only here, one other thing I added is this thing here. You must not override any existing schedule. Let's see what GPT-4 does. Okay, so you see over here, it still checks for available time slots, which means that, okay, I mean, at least it's better. Like GPT-4 just shifts it here and it ends the task. So you can see there's a marked improvement in terms of like splitting into subtasks and running it if you use GPT-4 compared to ChatGPT. And over here, you can also see that since the agent keeps thinking check for available time slots, it's thinking that this function checks the time slots also. So what this means is that, maybe if you see the LM doing something like that, you should make your function do the same thing also. So maybe you should name it better, like this schedule function could be not named schedule, schedule with time and appointment. Maybe you should have another function, or like you should check book time slots for existing schedule and must not override. Yeah, maybe you can do something like that. Be more explicit about where to check so that the agent knows where to check. Okay, because what seems obvious to us may not be that obvious to the large language model. They may not know where is our existing stuff. So if you check existing schedule, so ChatGPT again, like I have described it over here, you should check book time slots. And over here, it still uses this thing here. So it's the naming, you see, the naming here is schedule with time and appointment. It thinks that this can check also. So yeah, more needs to be done in terms of improving the prompt for this. But you can see this is the current existing difficulties with agentic framework. Like matching it to the functions is not an easy task. And in TaskGen, in order to match to the existing function, the description needs to match very well with regards to what the user wants to type. Okay, this is not a solved problem. I think the other agentic frameworks also have such problems. But once you have gathered your description well, okay, that suits what the large language model has been trained with, it's actually very, very smooth sailing. So actually one way to solve this kind of thing, like for existing schedule, you can actually do like memory. Okay, so there are memory I cover another time. I think it's quite late already. But so far with global context, you can see that there's a marked improvement in terms of how the agent does stuff because this is shown to the agent's context now. It's very similar to doing this. Where is it? Doing this. It's very similar to doing this. It's just that now we can do a lot more because this is the system prompt cannot change. Now we can dynamically, as the runtime goes, we can dynamically edit. Where is it? Yeah, we can dynamically edit this global context according to what has been run so far. So it's very, very versatile. I recommend everyone to use global context as much as possible. You just simply put in all the persistent states to your agent, and this will be used every time step. And to solve stuff like this, you just need to make sure that maybe you can create because they keep saying check existing schedule. You can create a function just to check for the schedule, or you can create memory to map this kind of instruction directly into this. Yeah, so there are a few ways to do this. So if you just keep iterating over what the large language model would potentially respond to your system, you can create functions to adjust to what the agent thinks it needs. Yeah, and then eventually the system will be very, very powerful and works most of the time. So it's an iterative process. I'm just showing you how this can be done as a start. All right. To continue doing this, maybe I need another half an hour to 1 hour. So won't have time for that. But at least you can see how with more and more structures in TaskGen, the agent does the task better and better. Yep. So that's all for today's session. So I hope this is an interesting showcase of TaskGen. I think maybe I should have picked another task other than scheduling, because scheduling is not a good task for showcasing LLMs, but it does showcase the limitations of TaskGen as of now, and definitely will be improved. I think in the future, this global context thing, I hope to make it automated as much as possible, so that whenever you have your earlier subtasks, maybe it can be given to, like, okay, maybe I shouldn't automate this. Like, when you use TaskGen, you should try to use global context as much as possible, so that you give the right conditioning to your agent, and it prevents hallucination of all this kind of stuff. Yeah, like earlier on you say that if I don't restrict my subtask to 1, it just keeps doing the same thing again and again and again. This doesn't happen in GPT-4 Turbo. It's only like ChatGPT, because like it doesn't infer that well. So we have to do like constraining stuff like this to make it work. As LLMs progress, I can imagine that all this won't be needed anymore. So as LLMs evolve, this agentic framework will be very, very powerful. So yeah, that's a good note to conclude. And yeah, do try out TaskGen and let me know if there's any issues or anything that you need help with, and then we can improve this whole thing together. Okay, before I end, any last things?
Yeah, so I want to ask, like, how do I like how do we input things into memory, but not in a semantic way. Like, what I mean by that is, like, because memory right now is you it's like kind of like keyword based, right? So if I store it in global context, I to for the large language model to kind of like pick up this memory, you basically need to ask it specifically about it again. Or what if I want it generally, like like when you prompt, when you use a chatbot, you just throw in everything, you just throw all the text in.
So you want memory? Are you talking about this kind of memory? Mapping your task to your function?
No, like more in like a chat GPT way. Like when you ask chat GPT, when you talk to chat GPT, the conversation goes on and on, but basically it still remembers everything.
Okay. So basically for that, I'm actually creating a conversation class just for that. But what you can do is your conversation could be here. You could put your conversation here. And you just put like your agent.chat variables. If you have a chat variables for conversation, you could just put it here. This will make your agent know your conversation already in your memory. Yeah, you can just use this global context.
Okay, so then every time I do an agent dot run, I have to specifically say read, remember from conversation.
Yeah, so you need to initialize your conversation here, like this. And then what you do is, for every time you do the user and do the agent, you need to update this conversation buffer list. And then every time step, the agent will have this conversation as the grounding truth. I mean, we can take a look at tutorial 5. I have a chatbot for Shop Assistant. You can see that in the chatbot, there's a past conversation here.
Mm.
And this past conversation is every time you have a conversation, we update the conversation with
Yes.
the user message and the agent's message. And basically, this will be used whenever we want to do like the agent decision. The agent will take into account the past conversation as well to decide, okay, whether to buy item, whether to search items, and so on.
Oh, but what's the part that shows that it takes from past conversation?
Oh, here. So like when you run this thing here,
Yeah.
every time the user types a message, we will append the user. And when the AI agent responds, we'll append the agent reply.
Oh, okay. So I have to append it myself. Okay.
Yeah.
That
So
makes sense.
don't worry. All this in the conversation class, this will be all in a wrap up class, and then
Okay.
all this will be done for you automatically. But for now, do it yourself because I haven't finished yet.
Okay.
Yeah.
Cool. Okay. This will help a lot. Yeah.
Right. So I think eventually everything should as much as possible put in global context rather than subtask completed, because as you saw earlier, the subtask completed, the more we have in the subtask, the more the agent hallucinates in terms of like sometimes the agent just keeps trying to book the time slot again and again and again, right? Like you saw just now.
Yes.
Yeah, that is actually the LLM's issue. Like right now, the LLM just tries to pattern match. But because I'm also using the LLM to check whether a task is completed, sometimes the check whether task is completed, it didn't do that well. Like, okay, so this is the issue with LLMs right now. They are not very good rule-based checkers. So if you want to ask, has my task been completed? You ask the LLM to do that. 90% of the time, maybe it says yes, 10% it says no. You know what I mean? Like it's best if we have a hard objective that can be evaluated without LLMs to see whether the thing is done. Then that will be a good feedback loop to the agent. But right now we don't have such things. Yeah. So and it's very hard to customize a checker for every single use case. So we have to rely on the capabilities of the LLM to see whether they know that the task has been done. That's why we have these issues right now.
Okay.
Yeah. And all these issues will be solved with the LLMs getting more and more powerful. Or if you put the additional context, it actually helps the agent better ground what they need to do. So I find this global context very, very useful for that. And with global context, actually, it helps the agent hallucinate less.
Okay. And just one more question from me. I want to know like what's the difference between the decision making for meta agent when they call the inner agent versus when inner agent do subtasks.
Actually, the decision is the same thing.
Oh,
When
it's
we
the same.
call an inner agent, it's actually running the same loop as the meta agent. It's just the inner agent will have a different description.
Okay.
Yeah, different description of agent name and description of agent description.
Right.
And yeah, different functions also. But it just runs the same kind of planning loop as the meta agent.
Okay. That's interesting.
Yeah.
Okay.
Well, I mean, I guess I could ask a question. I mean, it's more involved with the retriever class. I know we didn't really get into it, but I guess I can ask it right now.
Yeah, sure. Go ahead.
I, I was just curious about like when it pulls up the embedding values from like whatever embedding model you use. I know the models that are typically being used, like Ada or the embedding 3, they are vector length 1 when you do the final return for the dot product. So like I've seen a couple embedding models and they're kind of all over the place. Like some of them have more extreme vector lengths, some are normalized to 1. So I was just wondering if that like had any effect or if you've had any experience with that or if you've just been using the standard vector length 1 models.
You mean vector length one, you mean magnitude one?
Yeah, magnitude 1, yeah.
Yeah. Okay. So in dot product, what we do is we normally do this. Where is it? Yeah. We just do a dot embedding here. So typically if you do cosine embedding, you need to divide by the magnitude of your vectors. So if you look here, you need to divide cosine theta is a dot b divided by magnitude a magnitude b. Right now, if we look at the way that I did the embedding, I just assume that the embedding is already normalized. Yeah, so that I save some runtime. But in general, you could actually divide this by the magnitude of this query embedding and magnitude of key embedding. You need to normalize it, because if you don't normalize it, your cosine similarity will not be a apples to apples comparison for the different query key vectors. Yeah,
Okay, so it is nuanced. It does have an effect. Okay,
it does. It does. You definitely
yeah,
need to do this magnitude A, magnitude B division. If not, you won't get your cosine theta.
got it. Okay.
Yeah. So over here, I leave it open. Like, you can also do your own embedding. Like, you can do your own self-ranking function. In fact, what I recommend is that instead of using this memory class to do the ranking, over here, what you can do is you can pass it to a vector database, and the vector database can then retrieve for you the vectors that are similar. Like, so this memory class only needed when you don't use vector database. I just created this just to illustrate how to do this. But for real industry use case, I still recommend linking up directly to a vector database instead of using this memory class. Like, okay, if we look at the way that the memory is done, all that needs to be done here is that, okay, let's take a look at this. I didn't really touch on memory today, but memory is like this. You define a memory function, your top K, your mapper, and so on, and what approach it is. All this actually, you can create your own memory class. And you can, in this step, like retrieve, you can just replace by the vector database retrieval step. Yeah, you don't have to use the TaskGen memory. TaskGen memory is actually a bit inefficient for large number of vectors, because I do the comparison one vector and one key at a time. Which means that if you have 1 million keys, you need to do this 1 million times. Vector database, they have like PQ vectorization and so on, like those kind of product quantization. They have all these things, and like nearest neighbor search that will help to speed up the runtime a lot. So I still recommend using vector databases for larger projects.
Very cool. Okay. Okay, so it would speed up, but would it improve performance potentially, or it would still be the same at the end, wouldn't it?
Normally, the speed up will decrease performance.
Mm,
Yeah, because they
okay.
do approximate search, so you miss out some stuff.
Right. During through the database, it loses out values, compresses. Okay. Yeah.
Correct.
Mm.
Yeah,
I will
but
experiment and see. We'll
yeah, try
experiment.
it out. Let me know what works, what doesn't. But you can
Yeah.
see, even though it may not do well for multi-step planning, at least for single-step planning, to match it to the function itself, if you look at this function calling, it actually does it quite reliably. So I think at least the main thing to solve for this large language model is like multi-step chaining of the plan. Okay, that is a challenge, because that one, you need to know the output of the earlier functions, and then you need to replan again and so on. That will be better help. That will be actually rather than using subtask completed, I realized that the LM looks at global context way more reliably than subtask completed. So moving forward, the multi-step process might be replaced with this global context. So I mean, TaskGen is still in development, and I think we'll go with whatever method that LMs understand best.
Alrighty, that's all for me. I just want to get that out of my head. Appreciate it.
No worries. Okay, yeah. Thanks for staying, and I'll see you again. Maybe next week we can do more on memory. Like I didn't go through much of memory, but memory is very, very important in terms of like how to map the I mean, just a brief teaser is like, how do you do rec across multiple functions? How do you like add some rec of some additional context? You can use memory to do it. You can also use memory to do functions, task to function mapping, so as to make more accurate mapping of what your user wants to what function you execute. So there are various ways to use memory. Knowledge graphs is also one kind of memory that you can use. Not shown here, but there are various. I always believe that to do a successful cognitive agent, you need to have multiple abstraction spaces, and this memory forms various abstraction spaces. And eventually, all this memory can go into global context. So at least that's the workflow that I'm thinking of right now.
Oh, that's cool.
Okay, I'll end
Yeah.
here. Yeah, thanks for everyone, and see ya.
Thanks, John.
Bye.
Bye.
Thank